Alright guys, so somebody in the group asked about this problem 3C here, using KVL to determine the current flowing. I actually meant to go over this today in class and I completely spaced it, so I'm going to go over it now in this brief video real quick. So I'm going to take not this particular circuit but a similar circuit. I'll just come up with one on the fly. Come on, camera. Alright, sweet. So, let's call this KVL review something. Alright, so basically, we're looking at a circuit that's got a resistor, I don't know, some voltage source, and then another resistor. And we want to know how we can find the current flowing in this circuit when we basically don't know anything. We don't know any of the voltages, right? So let's call this, I don't know, 2 volts across the battery. We'll call this 1K, and we'll call this 6K. How about that? Alright, so basically, we'll call this R1, we'll call this R2. So I know my current, the thing is, you're probably wondering, how do we know which direction the current is flowing? Basically, we know this voltage has to be higher than this voltage by 2 volts because of the battery. And if this voltage is higher than this voltage, then it won't flow that way through the battery, but it'll flow that way through these series resistors. So the current would be flowing this way. However, I'm going to show you that it doesn't really matter which way we define the current. All that matters is that you keep track of the voltage drops, whether the battery, basically the polarity of the battery is kind of the only thing we have to keep track of here. I'll solve it both ways so we can see both ways, and then you guys should have no problem with the homework. So let's say I define my current flowing counterclockwise. Or I call that I1, but I guess it could just be I in this case. It's just I. But since I labeled it I1, we'll call it I1. So let's start with the battery. We know across the battery that we're going from minus to plus. We're going up by 2 volts, so I'll write 2 volts. Across this resistor, we know that we're going down by I1 times 6K. So let's minus I1 times 6K. And then across this resistor, I write the plus to minus like this because we know that current flows from higher voltage to lower voltage. So if the current's flowing in this direction, then we have higher voltage here than we do here. And basically the same thing going this way. So what you're going to see is that as long as you define everything properly, the problem will work itself out. Because of KVL. So 2 volts minus I1 times 6K, and then minus I1 times 1K equals 0. So now if I solve for I1, let's go 2 volts equals, if I group those like terms, that would be 7K, and then I add it to the other side, so I1 times 7K. And I can divide by 7K, divide by 7K, and I can say that I1 is equal to whatever 2 over 7K is. I have my calculator here. So let's take a look. Oops. 2 over 7K. 285 microamps, so 0.285 milliamps. So that's my current. So now what would happen if I were to define the current in the opposite direction? So let's do it in another color. Let's say I defined my current, instead of flowing counterclockwise, instead I defined it flowing clockwise. We'll call this one I2. So if I were to go this way with the flow of things, I would say, okay, I'm going down on the battery. I'm saying, okay, so I'm going from plus to minus of the battery. So instead of, last time we were going up, so we said, like, basically this is a plus 2 volts. This time, when I go across the battery, I'm dropping voltage, so I'd say minus 2 volts. Now I come across this resistor, my polarity is flipped, and I drop basically by I2 times 1K, so I subtract I2 times 1K, and then across this resistor, I drop I2 times R1, which is 6K. And that whole thing's equal to 0, right? Now I can do the same thing I did. Let's go negative 2 volts is equal to, and then same thing, group the like terms and then add it over to the other side, so I get I2 times 7K. And here I get that I2 is equal to negative 2 volts over 7K, which is going to be equal to negative 0.285 milliamps, right? Well, this current of negative 0.285 milliamps basically tells me that the current is not flowing in the direction of I2, rather it's flowing in the direction of I1. So if I hadn't done all this math and I only did this loop and I got this negative, I could go, oh, okay, well that's negative, so then I know that my current wasn't flowing clockwise, rather it's flowing counterclockwise. So hopefully that makes sense. I just wanted to answer this real quick and make a brief little video on how to do it. Basically, all you need to really keep track of, you know what, I'm going to do one more example while I'm at it, just so that it's super clear. All you really need to keep track of is the batteries. When you're going across a resistor at any given time, you're going to be subtracting because every resistor has a voltage drop. You're never going to be gaining voltage when you go across a resistor. When you go across a battery, you may be gaining voltage, basically. If you're going from this node to this node across this voltage source, right, you're going up by 2 volts. If you're going from this node to this node, you're going down by 2 volts. So that's where you need to keep track of stuff, is with the batteries or the voltage sources. Any resistor that you cross, you're going to be dropping voltage, so it will always be subtracted. You notice I subtract, I subtract, I subtract, I subtract. It's never going to be added when it's a resistor. It may be added based on the polarity of the voltage and the direction that you define your current. So let me do one more example while we're here. Do another circuit. All right, let's switch colors. So let's say I've got, oh, I don't know, a resistor there, ground, resistor there, and then a battery here. Call this 6 volts, 1K, 2K, and 3K, right? So first, let's define the current flow clockwise. So clockwise, well, again, this voltage is higher than this voltage. These resistors are all in series, so the current will be flowing clockwise in this circuit, but let's just define it clockwise. So we'll call that I1. And we'll go ahead and I just want to clarify, when I found I1 and I2, there's not two different currents flowing in this circuit. I showed you guys two different ways to find the same current. So in this circuit, I called I1 the counterclockwise direction and I2 the clockwise direction. I just want to clarify, there's not two different currents flowing here. This is the exact same current. This is just defined counterclockwise and this is defined clockwise. It's the same current. So just to clarify that. So if I do I1, basically I'm going this from minus to plus across the battery, okay? So I'm going up by 6 volts when I go from this node to this node. So I would write a plus 6 volts basically. Then I drop across that resistor, I drop across that resistor, and I drop across that resistor. So I would say minus I1 times 3K, minus I1 times 2K, minus I1 times 1K equals 0. I group my like terms, so this is a 3 plus 2 plus 1, which is going to give me a 6K. So 6 volts minus I1 times 6K equals 0. I can add that to both sides. 6 volts equals I1 times 6K. Divide by 6K. Cancel. I1 is going to give me 1 milliamp, right? So now what if I didn't do it clockwise because I wasn't sure what direction the current was flowing? Instead, what if I did it counterclockwise? So let's see what would happen if I were to define the current counterclockwise. So I go across this battery, I'm going plus to minus across the battery, which means I'm dropping by 6 volts. So I'd have minus 6 volts. And then again, I drop across each of the 3 resistors. So I'd have minus I2 times 1K, minus I2 times 2K. I'm so sorry if you can hear that. I don't know if you guys can hear it, but someone in my house just started showering and it's incredibly loud. And I think this mic picks up everything, so if you can, I'm really sorry. Minus I2 times 3K equals 0. minus 6 volts, group-like terms, add it to the other side, divide by 6K, and I get that I2 equals negative 1 milliamp. Again, that's the same current. I1 is flowing clockwise, I2 is flowing counterclockwise. It's the same current, and I'm just defining it two different ways. But right, if I calculated I2 and I said that that's negative 1 milliamp, then I know that my current is actually flowing 1 milliamp in the opposite direction, right? So that's pretty much how KVL works when you don't know any of the voltages. It works the same as it does when you do know the voltages. It just looks a little bit scarier. So I hope this helps, and I hope you guys have a good rest of your evening.